Your app looks fine in development. Clean code, everything works, so you ship it. 3 months later, traffic grows. Your database CPU is pinned at 90%. Pages are timing out. Your DBA is sending angry Slack messages. You add caching, you scale the server, you add red replicas, nothing helps enough. Then someone finally runs a query log in production. And there it is. For one page load showing 100 posts, your app fired 101 separate database queries. You didn't write 101 queries. You wrote one. Your ORM wrote the other 100, silently, automatically, one per record while you weren't watching. This is the N+1 problem, the single most common cause of database performance issues in ORM apps, and it's dangerous precisely because it looks completely fine in development. Let's use the simplest example. A blog. Posts have authors. You want a list of posts, each showing its author's name. In SQL, the correct way is one query with a join. One query, one round trip to the database. Done. But you're not writing raw SQL, you're using an ORM, so you write something like this. Fetch the posts, then loop and read each post's author. Clean, readable, and completely reasonable looking. This is the trap. Here's what the ORM actually runs. Query 1 fetches all the posts. Then, for every single post, a separate query to fetch its author. 100 posts becomes 101 queries. 1,000 posts, 1,001. One query to fetch N records, then N more, one per record. N+1 total, that's the name. And the damage is brutal. Done right, 2 queries at 10 milliseconds each is 20 milliseconds. The N+1 version on 100 records is over 1,000 milliseconds, 50 times slower, and in the cloud, up to 50 times the cost. So why do ORMs do this? The answer is lazy loading, the default behavior of almost every ORM. When you fetch a post, the ORM grabs only the post's own data, title, body, author ID. It does not fetch the author. It waits. The moment your code touches post.author, that is when the ORM fires a query, just in time, on demand. And this isn't a bug, it's deliberate. Lazy loading is genuinely useful. If you fetch 1,000 posts just to count them, you never needed the authors, so you never paid for them. The problem is the loop. You iterate a collection and touch a relationship on every item. Each touch fires a fresh query. The ORM can't see the future. It doesn't know you're about to ask for every author. Underneath, it's a mismatch. Your object code says, give me the author of this post. The database wants all the data you need in as few round trips as possible. Lazy loading is where that bridge quietly collapses at scale. So how do you catch it? The trouble is, development rarely exposes it because your test data is tiny. 5 posts, 6 queries feels fine. 5,000 posts, 5,001 queries, and your database is on its knees. Same code. Method 1. Turn on query logging in development and keep it on. Every major ORM can log every SQL statement it runs. The signature of N+1 is unmistakable. The same query pattern, repeating with different parameters, back to back to back. Method 2. Use the tools built for this. Django's debug toolbar counts queries per request. The bullet gem for Rails alerts you the moment it spots N+1. Method 3. In production, use APM tools like New Relic, Datadog, or Scout. They flag the pattern automatically. If you're running in production without one, N+1 is probably costing you money right now. Now the fixes. The primary one is eager loading. The idea: tell the ORM upfront what relationships you'll need so it fetches them all before the loop even starts. 0 per item queries. In Django, select related uses a join, one query, all the data for many-to-one relationships. Prefetch related runs a second optimized query for many-to-many and reverse relationships. Rails calls it includes, Prisma uses include, SQL Alchemy has joined load, different names, identical idea. And the result is night and day. Before, 101 queries 1,000 milliseconds. After, exactly 2 queries 20 milliseconds. The pattern is the same in every stack. Tell the ORM what you need before you start iterating. Sometimes the ORM's eager loading isn't optimal for your case. The escape hatch is a raw join query. You write exactly the SQL you want. The trade-off: you give up ORM conveniences like type safety, automatic mapping, and migrations. So use it for hot, performance-critical paths, not as your default. The third fix is batch fetching, for when relationships are dynamic or decided at runtime. First, you collect all the IDs you need. Then you fetch them in a single query using an in clause, where id in the full list. N separate queries collapse into one. This is exactly the trick DataLoader uses in GraphQL resolvers, and it works for any relationship type, even the messy conditional ones that eager loading struggles with. But here's what separates the senior engineers. Not every N+1 is worth fixing. Leave it alone when N is small and bounded. A dashboard that always shows 5 items is fine at 6 queries. And leave it when the data comes from a cache like Redis. Those aren't hitting your database at all. Also respect eager loading's own traps. Overeager loading, pulling everything just in case, bloats memory and bandwidth. Load only what this operation needs. And never chain eager loads into a circle, post to author to their posts to author again. That path explodes into recursion, and your ORM may not warn you. The rule above all: measure first. Confirm it's actually N+1 before you touch anything. Then, to keep it from coming back, assert the query count in your tests, run bullet or N+1 in CI, and set APM alerts. A regression should fail a test today, not surface in production 6 months from now. So altogether, the N+1 problem is an ORM's lazy loading firing 1 extra query per record in a collection, turning 2 queries into N+1. It's invisible in development and catastrophic in production. And it matters. Every 100 milliseconds of page load costs you roughly 1% of conversions. The fixes in order of preference: eager loading first, a raw join when you need full control, and batch fetching for dynamic relationships. Detect it with query logging, the bullet or N+1 tools in CI, and APM in production. Lock in the query count with test assertions so regressions surface immediately. Because this is one of those topics that separates developers who understand what their ORM is doing from the ones who just trust it blindly. Drop your ORM in the comments and subscribe for more backend fundamentals.